Welcome to this video on power and efficiency, designed to help you with your GCSE Physics revision. We will explore how quickly energy is transferred and how efficiently devices make use of it. In this video, we will cover the definition of power and its units, the key power formulae, the concept of efficiency, how to improve it, and essential exam tips. Let's start with Chapter 1, Power. Have you ever wondered what it actually means for energy to be transferred quickly? Power is the rate of energy transfer. Simply put, it measures how fast work is done. A high-power device transfers the same amount of energy much faster than a low-power one. Power is measured in watts, named after James Watt. 1 watt is defined as 1 joule of energy transferred every second. We use kilowatts and megawatts for larger-scale measurements. When performing calculations, ensure your units are correct. A common exam mistake is mixing them up. Always remember to convert minutes into seconds by multiplying by 60. Moving on to Chapter 2, the power formula. We will look at how Tau's energy transferred and time to calculate the power of a device. The most common equation for power is P equals E divided by T, where P is power in watts, E is energy in joules, and T is time in seconds. You can rearrange this formula to find any missing variable. For example, to find energy, multiply power by time. The example on screen shows a calculation for a kettle. Power can also be calculated using work done. Since work done is a method of transferring energy, the formula remains P equals W divided by T. This is particularly useful in mechanics. Remember, 2 machines might transfer the same energy, but the one that does it in less time has a higher power rating. Power is about how quickly, not just how much. Appliance ratings give us real-world examples. A kettle, for instance, has a high power rating because it needs to boil water rapidly, unlike a phone charger, which is much slower. Here are some practice problems. Pause the video and try to solve them before checking the answers provided. Finally, Chapter 3, Efficiency. This topic focuses on how well a device converts input energy into useful output energy. Efficiency is the comparison of useful energy output to total energy input. An efficient device minimizes waste, which is usually transferred to unwanted thermal stores. Let's look at the efficiency formula. Efficiency is found by dividing useful energy output by total energy input. You can present this as a decimal or a percentage by multiplying by 100. Understanding whether to provide your answer as a decimal or percentage is vital. Remember, efficiency can never exceed 1 or 100%, so if you get a result higher than that, check your work. Here is a worked example. A light bulb takes 100 joules of energy and produces 20 joules of useful light. By dividing 20 by 100, we find the bulb is 20% efficient. Sankey diagrams are excellent visual tools for representing energy. The width of the arrows shows the energy amounts, with useful output moving straight and wasted energy branching downwards. In reality, no machine is 100% efficient. Energy is always lost, most commonly to the thermal store through friction, air resistance, or electrical heating. Energy that is wasted is often said to be dissipated. Whether it's from friction between moving parts, electrical resistance, or sound from vibrations, this energy is difficult to recover. Next, let's explore how we can improve efficiency to ensure we waste less energy in our machines and systems. Lubrication is a key method for reducing friction. By using oil or grease, we allow moving parts to slide more easily, which reduces energy lost as heat. Insulation is vital for reducing unwanted heat transfer. Methods like cavity wall insulation, loft insulation, and double glazing help trap heat and maintain temperatures more efficiently. Engineers use various other strategies as well, such as streamlining vehicles to reduce drag, using low-resistance materials, or implementing systems like regenerative braking. When comparing technologies, it is clear that modern advancements are far more efficient. LEDs and modern electric motors, for instance, outperform their older counterparts. To wrap up, here are some final exam tips to help you secure the highest marks possible. Remember, power is about speed. If you are asked to compare devices, focus on how quickly they transfer energy, not just the total amount transferred. Watch out for common pitfalls. Always convert your time units into seconds, and ensure you use the correct units like watts for power and joules for energy. Finally, in efficiency problems, always divide the output by the input, and remember to multiply by 100 if a percentage is required. Never claim 100% efficiency as possible. This slide provides a clear summary of all the key formulae we have covered. Use this as a reference to ensure you can confidently recall, apply, and rearrange each equation during your exam. Next, we have the essential definitions. These are often tested directly, so make sure you can write these accurately and concisely to pick up those easy marks. Try this exam-style practice question. It combines energy transfer, power, and efficiency. Pause the video to solve it yourself, Then check your working against the model answers provided. Let's do some quickfire revision. These questions cover the core concepts we've discussed. Cover the answers on the right and test your recall. You're all set. Remember these key takeaways. Power is the rate of energy transfer. Always use seconds. Efficiency is a ratio between 0 and 1, and focus on reducing wasted energy. Good luck with your revision.